Hi, my name is Charlie Sternberg. I am a product manager at National Instruments, and we're here at Sensors Expo today to show you an overview of our CompactDAQ measurement system. It's a USB modular I/O system that I have sitting right over here. The idea behind CompactDAQ is to use these modular I/O pieces, whether you're using digital I/O, analog I/O, accelerometers, etc., to mix and match and create your own measurement system. With me here is Sam, and what we're going to do is use LabVIEW to create a simple data acquisition application using some accelerometer measurements. So let's go ahead and jump right into the LabVIEW application. LabVIEW is a graphical programming language. What that means is everything's done visually. There are no lines of text. There are two main windows, the front panel here on my left and the block diagram on my right. Front panel is where you can place things like buttons, knob styles, etc. The block diagram then is where I do my code. Because LabVIEW is graphical, there's no sequential lines of code. Instead, what we do is wire different terminals together. Now today what we're going to be doing is using the DAQ Assistant, which is a wizard-like interface used to create measurements and make them easy. We're going to go ahead and drop a DAQ Assistant down on our block diagram here and take those accelerometer measurements directly off my CompactDAQ system. So we'll drop that on the block diagram and you'll see that a window appears. We want to acquire some analog signals, so we'll select analog input, go down to accelerometer measurements, and it's going to launch the wizard interface for me. You can see it detects 4 channels that I can acquire from corresponding to the 4 channels on my CompactDAQ system. We'll go ahead and select channel 0, click finish, and here I can configure things, my acquisition rate, the excitation, the voltage input, etc. All I'm going to do is change my acquisition rate to continuous and then set it to 50 kilosamples per second to pull it into my measurement system. Let's type that 50K in, hit OK here. And what the DAQ Assistant is going to do is generate LabVIEW code for me in the background. The idea is that it's easy to use, it's simple, generates code for me, I don't have to program it myself. LabVIEW is even going to ask me, you selected continuous, do you want a loop going around it? Yes, we do, so we'll click OK. And LabVIEW's generated all my code. The final step then is to create the user interface, or the front panel. So we'll go ahead and create a graph, put it on our user interface, and the very final step then is to hit the run button. So we'll drop that down, come over here, hit the run button, and we can see that we're acquiring some vibration data coming from my system. If I bang on this chassis, we should be able to see the corresponding accelerometer measurements on the screen. So that's a basic overview of LabVIEW. Now, with our CompactDAQ system, we were using C-Series I/O, and we've expanded that platform to include some FPGA-based technology, such as R-Series and CompactRIO, and we're always looking at ways to expand our measurement platform. Here at Sensors Expo, we've seen a lot of wireless technology, and we're actually previewing some prototype DAQ hardware using an 802.11 radio. The idea is the same. I take my C-Series I/O, and I program it using LabVIEW, taking the same accelerometer measurements that I have with my CompactDAQ system. We can jump back over to LabVIEW here, and we can see that with the same code, I'm taking the same measurements and actually acquiring from my accelerometer. You can see my voice here appear on the screen, streaming measurements wirelessly from my radio link here. And that's all we have in our showcase here. Check out ni.com wireless for more information.